Chapter 3 covers the Ethernet port of the microcontroller. In the lab, you'll be able to view and modify a web page served up from the device's flash memory. The Ethernet peripheral has a long list of features, and I'll just touch on a few of these. The module is 10 base T and 100 base TX IEEE 802.3 compliant. It's full duplex and half duplex at both data transmission rates. It conforms to the IEEE 1588-2002 timestamp precision time protocol and the IEEE 1588-2008 advanced timestamp specifications. These protocols impart CAN bus-like predictability to Ethernet communication. There are 4 MAC address filters to offload the CPU from handling every Ethernet transaction. The module supports both IPv4 and IPv6. A DMA controller is integrated into the Ethernet module. It acts as a DMA master and does not need to be serviced by the DMA module. Crossover support and automatic polarity correction are included. Note the separate DMA controller and the transmit and receive FIFOs. These FIFOs are 2 kilobytes deep and are separate from the system memory. The Ethernet module circuitry is run on the system clock, the same one as the CPU. The physical interface, or PHY, can be run from one of 3 sources: the main oscillator with a 25 MHz crystal, the PLL through a divider, or an outside oscillator through the port M pin 4 input. A separate 25 MHz crystal to drive the PHY is not required. The external Ethernet port circuit is very simple. Only a few passive components, an ESD protection array, and an isolation transformer connector are required. IEEE 1588 adds a clock and ID address to permit synchronized operation between devices that have these added features. The clocks in an IEEE 1588 system are typically used to coordinate the activities of the primary applications executing on the system. If sensor data is time-stamped at a source, the time-stamped data may be correlated in post-acquisition operations. A single master sends time synchronization messages to the slaves with nanosecond accuracy. Remote slaves can then be instructed to perform an action at time t and can report measurements at time t plus delta. Since the clocks are synchronized, the resulting actions are coordinated in time. Most of the 1588 protocol is performed in the hardware. What is done based on the time is handled above the UDP layer. MicroIP has a very small memory footprint and is used in the bootloader. It has an available web server, but the lack of DHCP forces using a static IP address. Lightweight IP is used in the example apps since it contains DHCP and Auto IP and all protocols required for web server implementation. Both are offered under BSD-like license. TI's RTOS contains a full implementation of Ethernet stack functionality. Other third-party stacks are available with higher capabilities and a larger memory footprint, but they also have a higher cost. In Lab 4, you will experiment with the Ethernet port. We'll import and run an example from TivaWare and examine its details. We'll experiment with 2 methods of web control. Finally, we'll modify the web page in Flash so that you can see how it's built.